Hello there, friend. Nice to see you back. This time, let's use graphics to create something interesting in Python. I'm going to make a program that has a sine curve, so I'll call it sine. And in my program, I'm going to import a graphics library called tkinter, but I'm going to call it tk in my program. I'm also going to import time and import math. Then we do a little bit of initialization to set up the graphics environment. That's going to require us to create a root type object and create a canvas object. The canvas is what we're going to be drawing everything on, and the root is kind of the behind-the-scenes initialization for the window itself. We'll give the window a name. We'll call it sine. This is what's shown at the top left corner of the window when we run the program. And then, at the very end, we're going to destroy the window. But what we do before destroying it is what's interesting. So we want it to draw a square to the screen, or a rectangle, and after doing that, have the rectangle move around the screen. To do that, it's kind of like stop motion. We need to draw the rectangle, change x and y coordinates of rectangle slightly, then loop back. And these two things are really all we need to animate something in Python. Okay, so let's actually put it into a loop first. Let's have x represent the x coordinate of the rectangle. And we're going to have x go from range 1 to 400. What this is going to do is we want the rectangle to slowly move from the left of the screen, because 1 is the leftmost pixel in a window, to the right side of the screen until it reaches pixel 400. Before we do anything, let's do canvas.delete, and this is just going to refresh the screen so we're not drawing a ton of rectangles on top of each other. At the bottom of the loop, we're going to update the canvas. If we don't update the canvas, then nothing will ever get drawn to the canvas. Finally, we add a time.sleep. And what this is going to do is delay the animation slightly so that we can enjoy it a little more. Okay, so here we have our blank canvas window. We can see that nothing is being drawn. So for now, that's not really interesting. We're going to exit out of here and have it actually draw a rectangle. Okay, so now that we're back in our program here, between these two lines, the deletion of everything, and between line 18, that's where we're drawing or updating the canvas, we are going to do anything we want. For example, we want to draw a rectangle. To do that, we put canvas.create rectangle. Notice that this dot signifies to us that canvas is an object. So the window we see, the blank window with pixels, is actually an object in the way that tkinter handles graphics. And this object has a function called create rectangle. Somebody else made this function, so we just need to know how to use it. Now, create rectangle takes two arguments. One is a list, and the other is a color. So we can fill it with, let's say, green. So this will make a green rectangle, but it won't do anything unless we actually fill these coordinates here. And the way it works is that it takes four values: x1, y1, x2, y2. The way it works is that x1, the first variable in the list, is the top right corner x coordinate. coordinate of our rectangle. Y1 is the top right corner y coordinate. X2 is the bottom right corner x coordinate. And y2 is the bottom right corner y coordinate. So we have to know a little bit about the geometry of the screen if we're ever going to make a rectangle appear. So let's just keep it simple for now. Let's have x1 be 50. So the top left pixel will be across the screen 50 pixels. The top right can also be 50. The bottom right corner can be, let's say, 200. And the bottom right corner y value can be 100. So if we run this program, I wonder what's going to happen. So I'm actually missing a line up here. On line after creating the canvas object, I need canvas.pack, which is kind of an initialization call for the canvas object before it'll let me draw anything to the screen. So now that that's added, let's run the program now. Okay, so we see now a rectangle added to the screen. I edited the parameters just a little bit before I printed it, but across, we see it's a lot wider. That's because I had x2 and y2. x2 is much further out than x1 is. So x1 is the top left corner. The x1 width would be the bottom right corner. The height of it, would be the difference between y1 and y2. So we can just play around with the values and make it. So now we're looking back at our program here. You see that I edited the values a little bit. I made x1 be 10 pixels, so that's why it was so far to the left of the screen. From now on, though, let's have x1, the top left x coordinate, just be x. Remember that we're looping through x. So x is going to increase each time this for loop iterates. Y1 will be equal to the following. Here I have a sine curve. I put divide by 20 because I want it to be not too frequent. So the division by 20 will let me alter the frequency of the sine curve. The times 50 lets me update the amplitude of the sine curve. So if you don't have that, your amplitude will only be up and down 1 pixel, but as it is times 50, it'll go up 50 pixels and down 50 pixels. And let's see, what if we just keep x2 and y2 the same? What's going to happen? So we see now, when we open it, that this corner here, which my mouse is on, represents x1, y1. We see that it moves around. The x1 continues to increase constantly. Y1 moves in a sine curve-like fashion, but y2 and x2, which is where my mouse is now, is static. It doesn't move because we set x2 to 100 and y2 to 100 as well, so that corner doesn't move at all. We want our rectangle to move both corners at the same time, so the rectangle has a constant size. So what we'll do is make x2 just x1 plus 50. And then y2 will be y1 plus 50. This will give us a 50 by 50 rectangle, because the bottom right corner is always just an offset of the top left corner. Okay, let's run that. Well, there we go. We have a rectangle. I mean, it's a square, but a square is a rectangle. We have this square moving around the screen from the left to the right in a sine curve-like fashion. Once it reaches pixel 400, once x1 equals pixel 400, then the program will end. So in my program now, what happens if I remove the line canvas.delete all? Remember, canvas.delete all is refreshing the previous iteration of our window. If we don't delete all the previous rectangles, then let's see what happens. We see that the square moves in the same fashion it did before, from left to right, and in a sine curve-like fashion, but all of the previous squares on previous iterations are not refreshed. They're not deleted. So because we're not refreshing the screen, we continue to draw the square upon subsequent iterations, but we never delete the previous iterations. So we just keep all of the squares drawn on top of each other. We want to make something a little more advanced in tkinter this time. We want to create a checkerboard. So make a new file. What we want is we want to create a bunch of rectangles, but have every odd rectangle be black. That is odd with respect to the row or column, and otherwise we'll make it white, and that way we'll have a checkerboard. So this program creates a checkerboard. Of course, we were going to use tkinter, so we're going to import tkinter tk, import time, some initialization so that tkinter has a window to draw to. This time, of course, we'll define a frame width and a frame height. And what this will do is have a set number of pixels for a window to open. So to do that, we have to do it both to the root and the canvas. So root has a geometry function, which takes a string. We could do 800 by 300, but we have two variables that we can use. So instead, we can use frame width, and then frame height. And then geometry, the function knows what to do. From there, we create a canvas object, and we run its sort of initialization function here, which is pack. That sets things up, otherwise nothing will show to the screen. Canvas also needs to have its width and height defined. And it's done a little differently here. I'm using this config function. So once you have all this copied down, we're ready to be more creative. We'll give it a title so that a title will open up whenever we open up the window. We'll call it checkerboard. And just as a sanity check, let's see that this works. Okay, no error. That's good. That means at least it's running all these lines. At the end of our program, we're going to destroy the root. That'll destroy the window. But until then, we want to be in a loop. And this loop will continue to go on because it's always true. In this loop, we'll do what we did last time. We'll delete the canvas. We'll update the canvas. And then we'll sleep 1/10 of a second. Once all of this is set up, we're ready to really begin the checkerboard portion of this, because up to this point, this is really what you're always going to write if you're going to try to animate anything. We're always going to have a loop. We're deleting everything, pushing it the canvas, and then sleeping. Everything before the loop is just generic configuration that you're always going to put whenever you want to have a window open in tkinter. So what we put between lines 15, delete the canvas, and between lines 18 is original. It's where we're drawing the rectangles, or we're performing the logic itself to where the rectangles need to be drawn. Now, a checkerboard is somewhat of a 2D array, so let's iterate on a variable called y on range 8. So this represents rows. Represents rows. So a checkerboard, of course, has 8 rows, so that's why it's going from 0 to 7. Then, in that, we also want to iterate upon every column. So checkerboard has 8 columns, so we iterate from 0 to 7. That's how range works. It goes from 0 to the number before the number you put in. Now what we want to do is have the color be black unless the following is true. Actually, let's set the color up here first. Let's initialize it to black and have a size variable that represents the size of every little tile on the checkerboard. We'll do 20 by 20 pixels. So now every rectangle should be black if we do the following. Let's set a top left corner for every rectangle. We'll have it be x times size. And we'll have a top corner for the y-axis. That'll be y times size. The bottom right corner will just be the top left corner plus size. And the bottom right corner's y value will be the top corner, y1, plus size as well. So this will make a bunch of rectangles appear. They're all going to have the 20 by 20 pixels. And the reason this works is, let's think about what we're iterating through. We're iterating through x and y. On the first iteration, when x is equal to y is 0 and x is 0, the rectangle will be drawn at 0, 0 to 20, 20. Right? So that's going to make a 20 by 20 pixel rectangle from the top left corner of the screen, because 0, 0 is the top left corner, down 20 pixels and across 20 pixels to the 20, 20 mark. How about when y is 1 and x is 1? Well, then the rectangle will be drawn at 20, 20 to 40, 40. x1 and y1, which is represented here as 20, 20, is going to increment by size. So here we have time size, so every rectangle is going to be 20 pixels apart from the others. So I guess that's easier shown than explained. So let's actually draw the rectangle now. Do canvas.create rectangle. Give it a tuple, which is x1, y1, x2, y2, and we give it a color. So let's fill it with the color variable, which we defined up at the top. When we run this now. Well, there we go. We have a large black rectangle. But why is that the case? I thought we made 64 rectangles. We iterated y 8 times and x 8 times. That should be 64 rectangles. Well, the truth is this is 64 rectangles, but they're all next to each other, so you can't see the difference. Let's go back into our code. Let's have it so that x2 is x1 plus 1, and y2 is x1 plus 1. So all of the rectangles will still be 20 pixels apart from each other, but the bottom right corner of every rectangle will only be 1 pixel off from the top left corner. If we run that, there we go. And now we have 64 mini rectangles. They're still spaced apart by 20 pixels from each other, but they're drawn very small because we did +1 instead of plus size. Let's actually increase the size of that, 40, and let's make the frame a little bigger as well. Okay, so again, let's do plus size and plus size. and try seeing what happens then. There we go. One huge checkerboard created by 8 rows and 8 columns of smaller black rectangles. Let's just clear the screen here. Every time we click the X, it will give us an error. So we're just going to clear that. All right. So where do we go from here? We want to make it so that every odd row, the color alternates. So let's do the following. Before we enter the column, let's update the color, the global color variable, to white. Then, if y divided by 2 is 0, which means that if y is even, we're going to update the color and make it black again. So this way, because when y is odd, when divided by 2, its remainder is 1, so it'll stay white. But if y is even and it's divided by 2 and the remainder is 0, then the color switches to black. Let's see what happens then. Put an if statement here instead of a for loop. Okay, so we're getting there. We have every even row shown with white tiles, and every odd row is shown with black tiles. But that's not quite there, so let's go into our inner for loop where we're iterating across the columns, we're iterating across the variable x, and do the following. After creating the rectangle, let's do an if statement. If the color is currently black, let's make the color white. And if the color is currently white, so if it's not black, let's make the color black again. So this should just alternate between white and black every time we iterate on this inner for loop. There we go. So now we're iterating on and alternating the color between white and black, both on the rows and the columns. And we have a checkerboard. Let's slow things down and just see how it's actually being built. So within the inner for loop, we were iterating on the columns, both on the rows and the columns, so to say. Let's update the canvas. That pushes all the changes made up to this point to the canvas. And then, so that it's not instantaneous, we'll add a little sleep before iterating. There we go. Now, within the inner for loop, where we're iterating through both the columns and the rows, every time it draws a new rectangle, it pushes that change to the canvas and then sleeps. When all of the rows and columns have been iterated through and all of the rectangles have been drawn, it iterates on the while loop, deletes the board, and then redraws it. I've actually already gotten a head start with the next program. It's called boing.py because that's the sound that a ball makes when it hits something. Now the purpose of this program is to simulate a bouncing ball. So it's going to bounce across the side of our screen. It'll have a position, of course, a velocity, and an acceleration. So in my program, let's define a size for the ball. So this is just a global variable. It has nothing to do with tkinter. We'll just call it size so I can use it throughout my program. I'm going to get a 50 by 50 oval. So we'll set size to 50. We'll tab out so there's more room here. Now in global scope, what we're going to do is make a position for the ball. We'll call that x1. So the ball will start halfway across the screen. So we'll just take frame width and divide it by 2. And that'll mean that the top left corner of the ball starts in the center of the screen. The y-coordinate of the ball will start a little higher up in the screen, so frame width divided by 4. So not at the top, and not in the center, but somewhere in the middle there. Then we'll define a velocity. We'll call it vel x, so that's the velocity in the x direction. We want it so that every time the canvas iterates, every time we loop, the x1 variable, that is the position of the variable, will increase by this many pixels. So velocity will start at 2. Every time we iterate, we want x1 to increase by 2. So that's what these variables are going to do in our program. Velocity y, that is velocity downwards, velocity in a positive direction, will also be 2. Actually, just to start out, let's make velocity x is 0. Then we'll enter a loop. What we always do, we delete the canvas. At the very bottom, we update the canvas, and then we sleep. We'll sleep by 1/100th of a second. Now, what we do between lines 23 and 25 is all the logic for our bouncing object. So, of course, we want to create the ball. So we'll use the create oval function. The way it works is it takes a list and a color, red, and then optionally the width. So the width defines the black border that appears around objects in tkinter. It does that automatically. I don't really like it, so let's set that width to 0. This is an optional argument. So here I wrote a comment. Width is an optional argument. You don't need it. Create rectangle has a very similar width argument. You can set to 0 or to whatever you like. Now in here, let's do x1, y1, y1, x2, y2, just like we always do. And then, we actually haven't defined x2 and y2. So here, let's say that x2 is just x1 plus size. Y2 is y1 plus size. Let's save that and see if anything happens. There we go. We have a red ball appearing not quite in the center of the screen, but the center in the x direction, but a little higher in the y coordinate. So it works. It doesn't move. We're not actually using vel x and vel y, these variables here on lines 19 and 20, anywhere in our program. So sometime after clearing the canvas, but before drawing the oval, let's update x1 and y1. Remember, these determine the position of the ball. So x1 will be x1 plus vel x. Y1 equals y1 plus vel y. And we're going to see now that the ball is going to start moving. There we go. It moves down 2 pixels every time it loops. And it moves across in the x direction 0 pixels because we want it to move 0. Let's set vel x to 2 now. Okay, so that's nice, but it doesn't really move like a ball would. We want some sense of gravity. We want acceleration as well. So after drawing the oval, let's increment velocity in the y direction by 0.2. In essence, 0.2 is our acceleration in the y direction. Okay, so now velocity is going to increase every time it loops. And because velocity increases, the position of y1 is going to increase or have more of a difference as time passes. So let's run that. There we go. If you're paying attention, you might have missed that. Yep, so it drops slowly at the start, but then it begins to drop more quickly. The problem is it's not bouncing off the sides of the screen, so we're going to add 3 if statements to make it start bouncing off the sides of the screen. Before we draw the object, let's do the following. If y2, well, we'll set it like this. If y1 is greater than frame height, then the velocity is going to flip, so velocity becomes negative. Okay, so what happens if I remember frame height is, I think I set it to 800. Let's see. No, 600. So frame height is 600. So frame height, if we're checking that y1 is past frame height, then we're checking that the top left corner, its y value, the top left corner of the ball, we're checking whether it's greater than 800. I'm sorry, 600. Checking that the y chord of the top left corner of ball is not past the bottom of the screen. We're doing this line of code. And frame height, because frame height is 600, and we have 600 rows of pixels, frame height by itself represents the bottom row of the screen. So this is the same as checking the bottom of the screen. Notice, actually, it just bounced, and the top left corner was below the screen. We want it to bounce when the bottom of the ball is past the bottom of the screen. So that's why we're going to check, instead of y1, y2. Now it'll check the bottom right corner of the ball, or really just the bottom row of the ball. Let's do the same thing for the X position on the right side of the screen and the left side of the screen. So if X2, that's the right side of the ball, is greater than the highest column possible with our canvas, then let's reverse the velocity in the X direction. If the left side of the ball is less than 0, because 0 represents the leftmost corner of our canvas, then we'll also flip the velocity. So with these three checks, we're going to be checking the bottom of the screen, the right of the screen, and the left of the screen to make sure the ball doesn't go past that. If we run this, we see it bounces from the bottom, it bounces on the right over there, and it bounces on the left. It looks like it's not quite bouncing where we want it to, so let's go back in there and edit it a little bit, figure out what's going on there. We're checking the frame height. We should check the frame width. So the frame height is a little less than the frame width, which is why it was bouncing a little less than the right side of the screen. So now it should work correctly. So that's really cool, but I'd like the background to be a little more interesting. So we're going to make a lot of vertical and horizontal lines to fill our background. And you'll know what I mean once I actually run the program. To do that, let's loop through all of the pixels in the y direction, so from 0 to frame height. But we're going to skip every 40 pixels. Now in this loop, we're going to create a really thin rectangle. And this will be our line in a sense. We're going to make the line magenta. We're going to make the width 0 as well. Otherwise, you'll see a little annoying black border for all the lines. Now, in this tuple, we're going to do the following. 0, y, frame width, and y plus 1. So what this means is that the top left corner of every rectangle is going to be to the furthest left of the screen possible, because we have 0. x1 is 0 here. Y is going to increase by 40, so we'll see the vertical lines go down the screen. it will be as wide as the frame. So it's going to go from the left side of the screen to the right side of the screen, and every line is only going to be 1 pixel high. Let's see what this does once I run the program. So here we see that the lines are created by going down the screen 40 pixels at a time and drawing a line from the leftmost of the screen to the rightmost of the screen, and each line has a height of 1 pixel. Let's do the same thing in the for vertical lines. So we're going to copy this line. We're going to loop through all of the pixels across the screen. So all of the columns of pixels will also iterate through every 40. We're just going to change this line somewhat. So instead of appearing from the leftmost to the rightmost of the screen and being 1 pixel high, it'll be the top to the bottom. So that would be x0. And it'll be as high as the height of the screen. Every pixel is going to be every line is going to be 1 pixel wide. So we'll do x plus 1 in the third argument for the list. There we go. So now we've made the background interesting. We have a ball that bounces around. When it hits the sides of the screen, it will bounce off that. Because we have acceleration acting on the velocity of the ball, it's never going to hit the top of the screen, so we don't need to have an if statement to check if it hits the top.